Okay, good morning. That's fantastic. There's what, 54 of you here? That's pretty good for a Monday morning. We'll see if that's still the case a few weeks in time. I'm Matt Watkins. I did teach everyone a little bit of Python a few years back, but I didn't teach those of you on the maths course last year, so I've kind of lost track a little bit of you. Hopefully we'll manage to sort of connect up again. There will be face-to-face sessions on Friday. So what the aim, okay, short-term aim this week is to get everyone back sort of connected with numerical computing. So this basically means ensuring everybody has got on their computer, wherever you're sat, be it in your bedroom or living room, in your flat, whatever, has on your computer a working version of either C++ or Python, or preferably both, that you are comfortable opening up, seeing a mathematical problem, and you can start attempting to solve it. Obviously, later in the course, we're going to teach you different ways of solving different problems, but the whole point for the first week is just to get the having access to a platform to try and solve the problems out of the way. Let's try and get that solved. So I am going to give a slightly tedious, but really quite fundamental thing, sort of some linear curve fitting, as a sort of motivating thing, but the main point this week is to try and ensure that everyone has access to somewhere where they can do some calculations. And so the main thing, and throughout, is just to keep in touch with us, let everyone know what's going on, and if you do have problems, to get in touch. Don't just sort of suffer in silence. If you want to interject, please do. It's very weird sort of sat here in front of my computer talking into the ether. So do feedback in chat. I'll try and keep an eye on chat whilst I'm talking. Do raise hands or just type in chat if you want to say anything. Right. Okay, so numerical methods. I'm on the Blackboard site here. The module handbook. It's just got the main points that you might want to know. So the module equips the student with knowledge of various numerical methods for solving applied mathematics problems, their algorithms and implementation in programming languages. So it's not about the programming, it's about the numerical techniques, and the programming is only there as a tool to get this stuff going. So there's your learning objectives, applying numerical methods for curve fitting, so we'll start touching on that, and solving various equations, critically analyse applied mathematical problems, choose an appropriate numerical methods for their solution, and implement numerical solutions in efficient computer codes. I don't think we need to worry too much about efficient, as long as we get the algorithms working using a high level computer language. High level could be pretty much anything, it's not going to be machine code. Okay, how are we going to assess this? There's going to be two things. So every week, pretty much, I'll make it clear, I'll send out an announcement every week. But normally, most Mondays, not today because it's the first session, but most Mondays there will be a sort of mini problem put up that will follow on from the lecture I give. And you'll have until 3 o'clock the following Monday to solve it. So I'll give today's lecture is probably going to be a bit longer than normal because I'm introducing this stuff. But normally I'll give a 10 or 15-minute introduction to some new material, point you at some places to sort of look at it, and then so you'll have just over a week to attempt that problem. it will be more or less automatically marked, and a partial work solution will come back to you, and then the Friday I will sort of go through it, answer any questions that people have got, provide feedback on what's there. So that will be the weekly assessments, and that it's on the where are we, assessments, in the module briefing document. Let's open this up. You can see the weekly assignments contribute in total 30%. So they'll be continuing. The module, like scientific computing, goes over both semesters, so you'll have these weekly assignments this semester and next semester, and the total mark for all those little mini assignments, so there will be of the order of 15 of them or something, add up to 30% of the module. Where am I? Back to handbook. And the other thing will be there'll be 2 extended assignments that will be given out, one at the end of this semester, one at the end of the next semester. And there you'll be given a slightly more open-ended problem. Sort of, I've given an example of, you know, you've been given some data in some sort of scenario perhaps, and you're asked to build a model of it, fit it up, explain your method. And so you'll be given a couple of days. So it's not going to be sort of exam-y, but you'll just have a couple of days to work on this problem and submit like a mini project on that. And I'll expect you to sort of write out your understanding of the problem, how you've expressed it mathematically, and then how you've chosen a method out of what you've been learning over the term and applied it to the problem. Explain how you've done it, give your code, write that code in a good way, and present your results, and so on. There's going to be a full rubric explaining the requirements for each of these standards up on the site, and we'll give you some examples and so on before that comes up. So essentially, the weekly assignments will be given out. You have a chance to try these little problems, get lots of feedback on how to solve the individual bits, so sort of build up a bit of confidence in doing it. And then at the end of the term, you'll get these sort of slightly extended tasks to tackle to give a real idea how you're doing. So deadlines, as I say, I'm going to set the short problems on Monday. Essentially, I'll open them up when this sort of session goes live, and then you'll have until 3 o'clock the following Monday to submit them. And then the feedback should come very quickly, and then on the Friday, I'll sort of go through it, any questions that have been raised about things. People are always going to ask about logbooks. My point of view is you should now, again, and this away from separating the numerical methods from the programming, you should now have got into the habit of keeping a notebook, a logbook of what you're doing. So I'm not going to be directly assessing those in this module. But I really do suggest that you keep in that practice, keep a logbook of what you're doing, how you're working up this stuff. It's a good way for you to remember how to do those little bits of those tricky little bits of code that that you'll need later on. And it is good professional practice. If you're working in most places and you do a bit of analytical work, you'll be expected to be able to show how you've done it, how you developed it. Another motivation is that obviously you can use these logbooks for future assessments and in the time-controlled assessment. So there will be a big boon to you. So they'll be getting you marks even if I'm not directly assessing them. So the sort of overarching topics we'll be covering are curve fitting. Curve fitting sounds a bit boring, but it's essentially building a model. So you've got some data. What sort of curve can I fit through it? And we're going to do the simplest curve this week, which is a straight line. Then we'll do numerical solution of non-linear equations, but we'll start off by solving linear equations first. the normal way of solving nonlinear equations is to sort of assume they're linear and keep attacking them. Numerical solution of ordinary differential equations. Yeah, there's solving systems of equations, so that's numerical solution of linear equations. Numerical solution of partial differential equations and elements of stochastic methods. Stochastic means random. So it's using random statistical methods applied to solve problems. They could come up in sort of financial situations, they can happen in physics. There's many places that they come up. And so half of those, so mainly the curve fitting, solution of nonlinear equations, and solving a system of equations, and touching on some types of ordinary differential equations will be this semester, and then next semester Bart will take over and he'll continue ordinary differential equations and then go into partial differential equations, which is a big field that'll take up a chunk of next term, and then elements of stochastic methods. Yeah, there's quite a lot of stuff there, but I'll emphasize again, we've got these small assignments that come out every week, and I'm pretty confident saying from the past, is it the 5th year we've run it? Basically, anyone that has regularly submitted small things, has followed along regularly and submitted those, has passed without any problem at all. So as long as you keep practicing week in, week out at the little things, building up some chops with the transferring the maths into the computer back and forwards, you will be able to do well in this module. And so tools. So in principle, you can use any high-level programming language. So if you want to do Maple or MATLAB, that's fine, but I'm going to give most of my examples in Python, and I will try and remember to put up C++ counter examples as well. If I do too much Python and forget C++, and lots of you are using C++, then do remind me and I'll try and add in extra C++ stuff. So for C++, there's many platforms available for you. As it's the one that you've used in the past, the obvious thing is to use Visual Studio. There's a link here in this handbook for where you can access it and download it. If you go to this module content, you'll find I've put a small video here about how to get hold of C++ and indeed Python. And I've put a sort of, if you do use Python in this Jupyter notebooks that I'm going to be using, I'll show you it in action in a minute. Then there's a link to an interactive notebook where you can have a play around, and it's got some sort of guide on how to use that. What was I? Handbook. Yeah, basically the end of this introductory bit. So the C++. So this is Visual Studio. I'm not sure Visual Studio really is the best thing in some, because it's very powerful, but it's quite big. So that's the initial suggestion, but if people are having any problems with it, then we can also provide some suggestions for other sort of online lighter weight versions. I'm going to be using Python quite a lot, and I tend to recommend this Anaconda Python, and particularly this Jupyter notebook as the sort of front end to Python, the way of interacting with it. And again, there's a link here to it, and you can just click on the download button and follow that and install it. Should work on Macs or Windows, or if anyone's using Linux, that as well. Okay, I think that's most of the sort of housekeeping. Are there any questions about that part of the business? Anything I've forgotten to say? Are people still awake? Okay. Okay, is attendance automatic? Chris has just reminded me. So I guess this is the very first session of the term, I think, for everyone. So yeah, you don't need to do anything in case it wasn't clear about online sessions. We'll keep a record of who's there, just so we know who's engaging. But it's the face-to-face sessions where you need to actually do the code entry and so on. So yeah, so Carly, yeah, you don't need to do anything for the online sessions. That's automatically sort of logs into Blackboard, but it's nothing as such is done. It's the online sessions that so at the face-to-face where you're actually physically in the room that we really need to keep a quite tight really keep an eye on the attendance, because it's also kind of linked to the track and trace thing. So it's important that we know who's in the room. It's not about really attendance monitoring in that sense. It's knowing who's actually been in the room there. There was also a quick ping about yeah. So if someone's directly pinged me thing. So yeah, I said Visual Studio for C++. Visual Studio can do everything. You can install Python into Visual Studio as well. So when you're installing, or later on, there's another option to install a Python option. Then later, I guess I'll try and go through it online while I'm doing it. When you're creating a new thing, you can choose whether to be C++ or Python. And most of the Visual Studio scaffolding will work the same for either language. Yeah, so Visual Studio, you can use it for more or less any computer language. Right. I guess if I was being professional, I would sort of, I'm not sure what will happen actually if I stop this recording now and then start a new one. Perhaps I will do that, and then this will have this sort of introductory session as one bit, and then I'll have the sort of start of the actual course for the next bit. So I'll do that. Let's see if that works. I hope it won't overwrite it or anything. No, I won't risk it. I'll test it before I do that. Let's have a sort of monolithic recording. We can put a link into the sort of time stuff. Okay, right. Joe's had enough of me. Right. Okay. As I said at the beginning, I'm going to mention some curve fitting stuff. So how to fit, in this case, a straight line to some data. So it's something doing for a long time. So it should be something where the problem is clear to you. You know what the things are. So the problem doesn't get in the way, and the thing is just checking that we can do it on the computer. As I say, there's no point this week sort of pretending you can do it. What we want to know is that everyone has access to a computer, that they can get C++ and Python on it, and that they can perform sort of fairly some of these operations that you've done several times before over years 1 and 2 in different languages, that you can do that, you're back up to speed, and then in the following weeks we can start to develop some slightly more sophisticated material. Yeah, we're on, I should say, how do you feedback to me during these sessions? You can put stuff into the chat. If this is what I forgot to say, on Blackboard, I've put the discussion forum here. I've put 2 forums. We can always create another one if anyone's got any sort of stuff. So I've put a technical problems one there. So if you know, for whatever reason Visual Studio won't install for you or something like that, post up there with some details of your, you know, which sort of computer, what operating system you're on there, and we'll get back to that. So if you're sort of outside of the sessions, that'll be quite a useful way to there will be sort of, it won't get lost in the sort of the thread of things going on. And in a similar way, general discussion, if you've got a question about what does this question mean, or sort of conceptual issues behind stuff and so on, if you post there, then I can answer it, or indeed, that's the other thing I forgot to mention, Chris Dickens, who's the demonstrator, is helping out on this course. He can also sort of chime in as well. So you should know Chris. Yes, he's just posted into chat. So Chris, you should all know him from the last couple of years demonstrating technical computing and scientific computing. So it's the same guy that you know. So he'll be helping out. And during these sessions when we're doing more technical stuff, if you sort of answer questions, ask questions here, then we can either go into breakout rooms, or probably I think the best thing is going to be connect via Teams and have little sort of face-to-face online sort of sessions where we sort of diagnose problems and help you out. So there's always going to be those two of us. I think the advantage of if you post in a general discussion is that rather than me answering one person, I can put a solution up there that everyone can benefit from. So whilst I'm very happy to sort of do little sort of one-to-one sessions, mainly on the sort of technical side, oh, this doesn't work, or this variable's not, you know, the thing's crashing. Anything that's a bit more interesting, it'll be better to put it up on the forum and actually have a sort of open discussion rather than just you sending an email to me directly and then me sort of replying individually. Right. Yeah, I'm going to keep going because, yeah, I can split it up individually and upload. Right. Curve fitting 101. Right, general introduction. This is going to mess up with what I did before. What is numerical methods? Yeah, it's using computers to solve numerical problems. And what it's not, as I say, it's more programming. There will be some in the background, but we're basically focusing on the problems. Why am I learning this? Well, basically, in the vast majority of jobs you're going to be going into, you will be expected as someone from this sort of background, from STEM, from someone in physical sciences, from mathematics, you'll be expected to be numerically competent. You'll be setting up analytical models for a company, for a research team, whatever, and being able to demonstrate that you've got competent skills in Python, in C++, numerical analysis, and how to break down a problem into something you can do on the computer is going to be a big skill. So maybe these sort of portfolio, mini project things will be really good things for you to bit of show in the future. What I want to really encourage you to do, again, perhaps this should have been module handbook rather than this, but consider this an extension of that, is to really try and break the problems down into little problems. If the thing looks big and you don't know where to start, it means you haven't broken it down into small enough chunks. And connected to that, do try and use pen and paper to really figure out what it is you're attacking before you actually just stare at the screen, open up Visual Studio with Hello World and think, oh, what do I do? So try and have a clear idea what you're doing. And test, and test again. Like, essentially write a line of code, then recompile, check it does what you thought it did. The other thing is save very regularly. I tend to work on a OneDrive folder that is sort of updated fairly regularly. If you do that with OneDrive, it will also keep incremental backups. So if you cock up your code, you can roll back to a previous version and see where it was that you did things. That's probably more important for bigger things than we're doing. But nonetheless, do back up regularly. And particularly when you're actually in the computer labs, if you're on the machines that aren't on the network, remember to put it somewhere that you can get a hold of stuff. So what we're going to tackle is least squares regression. So let's think we've got some sets of observations that are made repeatedly. So it could be every day a measurement is made. You know, we've been seeing those sort of data made recently. Or it can be a physics experiment where we're repeating a measurement. So we do it the first time. I'll call the first one the 0th measurement. So it's time 0, so I measure the time x0, and then I measure some quantity y. So I've got these pairs. So the x value and the y value, the first pair, and then the x value and the y value, the second pair. And I want to think, are they fitted to a model of this form? So that the measurement, the yi, so for instance, the y0 value is related to the x0 value by a0, some constant, plus another constant times the x value. So it's a straight line. There's an intercept with value x0, an offset from 0 of a0, and a slope, a gradient of value a1 times the x value. So it's related like that, plus an error, plus an e value. So it's called the error or the residual. And so if this is true, we've got some error on our measurements. How do we find our best values of a1 and a0? So that's building our model. We're assuming it's this sort of straight line relationship. And what's the best values of a1 and a0 to get those values? So here's our thing again. We do some complicated rearrangement to get the error on the left-hand side. So the error is our measured value of y minus our intercept with this parameter, our intercept that we're trying to figure out, and our slope times the value that's measured for the x value. And so to give us something to work with, what we're going to work with is actually the square of these errors. So we'll square the error at each point and add it up to give us a total squared error over all our data points. So there's our formula explicitly. So this is our sort of model underneath this red line. Our data points are these guys here, and we're going to square up each of these distances to give us our total error. And what we're going to do then is adjust the slope and the intercept to minimize this squared error. And if we want to minimize things, what do? We differentiate. So in this case, the two things that we're varying are our parameters, our a0 and our a1. These observations, the yi and the xi, are observations. They're not variables, they're things that have been measured. The things that we're trying to minimize, and so this sum, if you like, is a function of this a0, this error sum of a0 and a1. So we do a partial differentiation with respect to a0, holding a1 and remembering the other things are constants, and we get that that is equal to this, and that should be set equal to 0 if we're doing a minimization, and the same for a1. Just said. So we've got these two relationships. For just two values, if it's this simple, we can rearrange to get an expression for a1 and a0 in terms of our pairs of values. and n here, which is the number of observations we've got. So if you remember, my data went from 0 to n minus 1, so I've got n data points. So the simplest one is to start with this a1 value. So I've eliminated a0, if you like, from these equations, and then I've got this expression. So it's the number of data points times adding up the value of x at each point times the y1, and then minus the sum of the x points times the sum of the y points, etc. There's a similar expression for the a0, which is the average of the mean of y minus this a1 that we've already worked out there. So the sort of challenge for this week, there's a set of data in the last slide, is to go away and try and figure out this a0 and a1, and then you can compare that to, say, Excel or some other way of finding this intercept and gradient from the problem. So a bit of code. So as a sort of preliminary coding up those different ones, you might want to just tackle something a little bit easier. And the simplest thing I can think of, well, it's not the simplest one, but the one that's sort of got the same sort of shape, is to code up, summing up the numbers from 0 to 99. Here's some sample C++ code. So we can take this sort of code. Let's just see if we can fire up Visual Studio and see if there's any bugs in that. How do we do this? Create a new project. Let's have a Windows desktop application. No, we don't want that. Console application. Call it dest. Okay. It's in C++. One thing that's very important that people always forget in Visual Studio is to decide where to put it. I'm going to put it, I've got a folder in my OneDrive, Numerical Methods 2021, and then week 1, so I'm going to put it in there. Yep. And then I'm going to, there's a button here to have the solution and the project in the same directory. If you don't do that, Visual Studio sort of makes another directory underneath and sort of spreads things around, so it just makes life a bit easier. Depending on the speed of your computer, it should manage to create a hello world script in some amount of time. So I can do that, and then press Control F5, and we should get that. So the sum of the numbers from 0 to 99 is 4950. So I've used standard arrays in this case. A bit later on, I'm going to introduce you to a slightly fancier library that will make this sort of stuff a bit easier. So a bit harder in the short term, but easier later on when we're dealing with matrices. But that's what I want to say. So Visual Studio works. If I want to do this in Python, Jupyter Notebook, and it opens up this file browser by default in my directory. Go to OneDrive. Let's try and yes, no, that's right. Teaching numerical methods 2021. Numerical methods. I've already made this super complicated. New Python 3, and then I can copy pasta this into here, Shift and Enter to run the cell, and I get the same answer as C++, which is kind of reassuring. Again, these bits of code aren't necessarily the best things. We will talk about some sort of slightly better stuff as we go forward. But it's, say, the main purpose this week is I'd like people to get Visual Studio. It doesn't have to be Visual Studio, but some platform where they can write C++ and get it compiled. and sort of tackle these problems, and the same with Python. So some platform, again, I'm suggesting this Jupyter Notebook, but it doesn't have to be, where people can get that working. And then if you want to tackle some slightly more complicated things, you can also make the things in the sum a little bit more fancy. And then the actual sort of, what would have been kind of the mini problem if I was setting one in the first week, is to actually fit up this data to extract the intercept and the slope for this data here. So I'll do another little thing about good practice in terms of getting data into the code, but the data sets are small enough, and I think it's formatted in a reasonable way. You should be able to get it into Python or C++ relatively easily. Right. Again, what I wanted to say, that's it. But really, what we want this week is to find out, or sort of for everyone to be in a situation where they can actually, say, open up their computer, see, oh, I want to code up this sum, and they can just go and do it without, oh, how do I install it? Oh, it's not working, this, that, and the other. Oh, you know, this stuff to be avoided. We just want to get straight in and actually solving the mathematical problems. So that's your task, essentially, is to try and do these things. As I say, there was a short guide to getting stuff installed in the module content. There's the links in the module handbook. So there's this session, and then there'll be Friday session, some of you face-to-face, some of you online. And what I want is everyone to be able to sort of get up to speed during that time. You see, YouTube's done a particularly flattering thumbnail for me. I should adjust that. I need to get out of the habit of doing that. Any questions? Is anyone still awake? No. Okay, I'm going to stop the recording. Thank you, Chloe. At least that's sort of one. I'm going to stop the recording now, and then perhaps people will be more willing to come forward. What I haven't quite worked out yet, and this will be something good to figure out, is whether we're best off outside of the kind of the lecture bit, actually sort of working with Teams or Blackboard Collaborate. I'm still not quite sure what the best way of sort of getting conversations going and so on. So for now, I'm going to stop this recording, but people can talk to me in the chat, or you can send me messages in Teams. It's just, if you start typing my name into Teams and ping me there, then I'll do that. I might end up spammed to death, but we'll see what happens. Okay, so thanks for those two of you that are still awake, and I will stop the recording, and then we'll start trying to get stuff there. Again, the main thing is, if you've got questions, come and talk to us. I know it's weird. I mean, I've been talking at my computer for 40 minutes. That's definitely weird. So do come and talk to us, Chris and myself, and we'll try and get everything up and running. If you don't understand what you're meant to be doing, again, let us know.